Good evening. Just I would like to share some of my experiences in development of the reusable PPEs in this particular context. So this is my total presentation, about some 30 to 40 minutes, and this will throw light on the current situation and how we can control the this viral infection and the spreading of this viral infection through the textile materials as barrier. So this is my total presentation will cover. So let us go into the subject. So this, so the objective of this total presentation would cover some 4 or 5 important points. So basically, what is PPE and how the different types of PPEs are used for different applications, and more importantly, what are the different fabrics normally used in the PPE segment. That is also very important area. The seam sealing operation, which is going to PPE, because to be the important part of making the that we will team has got a lot of challenges, and how these challenges are overcome we'll be discussing in the third point, and standards, and also with the industry people, because many people are unaware of the standards. Exactly, they are looking for some antibacterial and some say antiviral. So which are the different types of standards we have to go for, and which would be useful for the product as to be used within the country? And suppose if we go for exports, the requirements are again going to be different. So these differences we are going to discuss under the testing standards for PPE. Next slide. Yes, basically, what is a PPE coverall? So PPE is basically personal protective equipment, and we have to understand this way. PPE is not exactly concerned with coverall, because many people assume coverall is the product associated with PPE. It's not so basically, because if you take a mechanical industry, you take a chemical industry, or any other industry, so every industry, wherever there is manufacturing happening for the safety of the worker, they are something is provided to protect them. So they are all coming under PPEs. So in the current situation, we consider coverall is one of the major PPE. Even mask is also considered as a PPE only. Suppose you wear a gloves, it's a PPE. So PPE is the total family name which totally protects a person basically. So in my presentation, I'm going to cover only about the coverall products, how they are manufactured, and what are the different niceties of the manufacturing. So particularly now this presentation would be covering about the infection prevention, because we are discussing the webinar only about the infection prevention, because in the COVID-19 situation, everyone is afraid of approaching somebody during travel, during talking to somebody, or even when you closely associate even with your own family members or friends. So this is situation right now. So we have to control the infection. So coverall is one of the important product which covers the entire body, so which will prevent you from the infection. So this is basically we use it for the infection prevention. So we have to understand the application, because different applications would warrant different types of fabrics, different types of shape of the material. So coverall would broadly cover into, for example, if there is a chemical industry, they will be using some thick rubbers and all for the alkaline and acidic conditions. Biological, no pathogens should enter. So this is the infection prevention case. And the thermal industries are there, mechanical industries are there. So there are so many industries using the PPE coverall. So in our context, it's going to be purely infection prevention with that focus, how the coverall is giving the functions for a human being, that we are going to discuss. I've depicted a picture with the non-woven coverall, which you could see here. And I think everyone must be aware that by the month of January 2020, these fabrics were banned by the government of India and majority of the states. because non-woven, we know the problem. It is very difficult for decomposing, and also it is not eco-friendly. And besides that, the handling of the material, pollution, lot of such problems were there, and all the states started banning this material. And because of the sudden COVID-19 pandemic, anyhow, we have to manage with the situation. People started using it. So this is the fundamental material, which is a non-woven fabric made of polypropylene or polyester. This is the complete body coverall. Only the face and the palms in the hands and your foot are only left free. So remaining all completely covered. So that will protect you from the infection. That was the idea. So the basic coverall is produced without a seam seal. That means a non-woven fabric completely stitched and made into this shape, and the stitched portion is not sealed with a tape. Normally it is called sealing tape. That tape is not used in the fundamental material. So this is prescribed normally for workers, healthcare workers who work outside. For example, even some hospital, somebody is working in the reception or in the material handling, maintenance. These people would require only this kind of materials, and most of these drivers, these people. And this PPE, this PPE would offer only a moderate level of safety, and the liquid penetration at the seam portion is not prevented because the seam is not sealed. So that's why the low risk people can use this kind of PPE coverall. So here we have to understand, mostly what whenever I interact with people, always people look at the utmost safety. Whenever a pandemic situation happens, everybody wants to use only the seam sealed, highly expensive, a thick fabric, and what do you say, a top sealed, high pressure bearing tapes are used, which is normally prescribed for the doctors who are working in the COVID department, COVID ward. But those coveralls, people want to use it because they want to ensure extra safety. So this is not required, because when, suppose if we go out for a purchase, go for a market, you want to protect yourself, maybe we can go with a simple coverall like this. The seam sealing is not required. This is the very important understanding we should have. And this is a single-use product because it is a purely a polypropylene sheet material, and it's very difficult for prolonged wearing. Also, only for such situations we can use. So after usage, suppose you go out, maybe you use it for some 5 hours or 6 hours for a shift time, then we have to dispose it, because during our exposure, a lot of pathogens or the virus and bacteria would be deposited on the surface. So, and the fabric is not suitable for washing. So this PPE coverall is not suitable for washing and reusing. It's a single-use product. Normally, such products are priced somewhere around, as the senior professor told, somewhere around 150 to 200 it is sold in the market, but it is a single-use product. Right. The next slide. Now, previous please. Yes. Now, the same coverall, now it is called a sealed seam coverall, where you could see the blue color tapes are totally sealed wherever the stitching is done. You can see the complete chest portion, the neck portion, the hood portion, the crotch, hip, all the portions. Wherever the fabrics are stitched, that stitch portion is closed with a tape somewhere around 22 to 25 mm width paste. That tape is completely sealing the seam portion. That means there is no opening at all. So with this material, the extra safety is provided, because even if somebody coughs close to your coverall, close to your body, even the water molecules will not penetrate through the stitched portions. So that is also covered with this sealed portion. So this gives a higher level of safety. And this is normally prescribed for the high-risk healthcare workers. Particularly, it is recommended for the doctors or the nurses who are working in the COVID ward because they are at the higher risk. Or any other spread diseasing, that is higher level of risk areas, we will focus on this. So liquid penetration at the seam portion is also prevented because all the seams are completely closed. And again, this product is also a single use product. It is used only for a shift, particularly 6 to 8 hours only it is recommended. That's all, then the material is disposed. This is prescribed for only the doctors. So with the non-woven material, basically there are only two types of PPE coverall is prescribed. One is with the seam sealing, one is without seam sealing. Depending on situation, we can choose. Next please. Now coming to the fabric, this is a very interesting part. Basically, to begin with, the PPE coveralls are made with a Spunbond non-woven fabric made out of polypropylene, because polypropylene is comparatively a low density fiber, so you get a better thickness and also the cost is lower. And for this particular coverall application, the recommended GSM, grams per square meter, that is areal density of the fabric, you could say, is 50, 70 and 90. These three are mostly used, and most of the developed countries, they recommend only 90. Even WHO says 90 GSM and above for the extra safety. I told you, as indicated earlier, it depends on the situation we choose the GSM. For a higher level of safety, we go for a 90 GSM. So these three GSM ranges available with the material, and the Spunbond PPE non-woven material comes in two categories. One is coated, another is uncoated. Uncoated, both sides you have got the similar appearance. In coated material, you could see the photograph which I have shown at the bottom, which is in the pale green color. One side of the fabric is glossy, which is the coated side. So the GSM would be split like this. For example, if you take a 90 GSM fabric, the weight of the PP fabric would be 75 to 80 GSM. The 10 GSM thick polyester, that is PE or PU film is laminated on which to make it a coated fabric. And during stitching of the garment, that is the coverall, the coated side is kept outside because that is totally hydrophobic in nature. No liquid will pass through, giving extra protection. So that way the coveralls are made. So mostly coveralls are made with only coated stuff. So in case of, for example, we take 70 GSM, 60 GSM will be polypropylene and the 10 GSM will be the coating weight. So put together it gives you 70 grams per square meter weight. So this is coated and uncoated. For a normal simple protection, you can go for a uncoated one, and particularly for this seam sealing and all, it is highly suggested to go for only coated. So in coating, again, there are two types of coating we recommend. So one is polyethylene and second is the polyurethane. Polyethylene is mostly used because that would seal completely, and polyurethane would give some kind of a breathability. Some pores will be there, but in industries mostly use only polyethylene. PE coating is predominantly used in the manufacturing industry. And this fabric, since it is completely coated, you cannot expect a breathability. And believe me, practically if you wear a coverall made out of these kind of coated fabrics, we cannot bear the sweating developed within our body just 10 minutes. Within 10 minutes, we will find totally sheltering because huge sweating will be there because there is no breathability at all. Then imagine a doctor is wearing such kind of a coverall for one shift of 6 to 8 hours. That is very horrible. This is the particular problem with this particular fabric. That is a non-woven coated fabric. Of course, it is cheaper, and again, it is a single-use material. Next slide, please. Fine. So in non-woven, the same polypropylene material The non-woven is produced now with a different technique, which is called, shortly in industry, we call it SMS. SMS contains 3 layers of fabric in one sheet. You cannot distinguish three. It will look like a single sheet only. The blue color picture I have shown at the bottom. So that will look like a single sheet. So where the layers are taken like this, the top and bottom layers are Spunbond. The mid layer is a melt blown. So during the manufacture of the non-woven, the melt blown is produced by surface melting of the fibers. They totally got stuck with each other by melting. They are all becoming a sheet. But whereas in the Spunbond, it is pressed with a high temperature where it is made into a sheet. So melt blown sheet will always give you extra protection. So that's why the SMS material will give excellent particle filtration compared to the basic Spunbond. So you could see from the picture, this contains 3 layers. The middle layer is the melt blown, so which can prevent the liquid penetration. So unlike the regular Spunbond, SMS material has got more liquid resistance because of the mid layer. So at the same time, because of the pores open, we could see that it is slightly breathable. Slightly, I won't say it is. We cannot compare this fabric with a woven fabric or a knitted fabric. Comparatively, compared to the previous Spunbond, this is somehow breathable. That's what we say breathable here. But liquid resistance is there. So this material, the SMS fabric, is not sealed. Whereas the Spunbond, which is coated on side, which will have a PE lamination, so that side which is completely sealed. So SMS fabric is also sealed at the seam portion, but this is not at all coated. So the coating is not there on both sides. So it is somehow breathable. This is the advantage of the SMS fabric. And the mid layer, which is the melt blown, giving the extra protection. So this extra protection offered by the melt blown mid layer makes the material even at a lower GSM. For example, 40 to 50 GSM of SMS fabric would be sufficient to make a coverall, which is a very good quality. But when you take a coverall with a 50 GSM of the previous one, the Spunbond, the basic Spunbond 50 GSM, definitely it would fail in the test at the last. But in SMS fabric, the same 50 GSM would pass because of the mid layer melt blown, which has got a very good particle filtration. So this melt blown is very, very important for the mask manufacturing, where they use in the inner layers, because particle filtration is very important for the mask. Next slide, please. Fine. This is mostly recommended for the export category. Here, this is a 5-layer material, shortly called SSMMS in the industry. So the top 2 layers are Spunbond. So 2 layers of melt blown. Then again, the bottommost is a Spunbond. So these 5 layers compressed together to make a single layer. So it will look like a single sheet, but it contains 5 layers of material, which is called SSMMS. This material is mostly wanted for all the export stuff. Whenever we go for export of this non-woven material, they choose only SSMMS because this is comparatively still better than SMS. So it's highly breathable compared to that. Still enjoys all the benefits like liquid resistance. But this material is almost, you can say the cost of this material is 2.5 times of this Spunbond. Spunbond, the current price is somewhere around 125 to 130 per kilogram of fabric. This SSMMS fabric would cost somewhere around 400 rupees per kilogram of fabric. It is comparatively expensive. So to make a coverall, you require almost something 3 to 3.2 meters of fabric. So when you multiply such a quantity of fabric, the cost of this coverall would be higher. So that's why in domestic industry, SSMMS is not mostly used. So it is mostly the people use it for the export category of materials. But still, it is single use only. All the Spunbond, SMS, SSMMS materials are only single use category. And particularly with this GSM, If you bring down to 25 GSM, the fabric on touch would be like a paper, very thin, 25 GSM. So that GSM fabric is mostly used in the mask as the inner layer, and in many of the contexts I have seen, the people, they also regard this SSMMS fabric as bell blown. Actually, melt blown is different from SSMMS. Melt blown comparatively, the strength is very weak compared to SSMMS. So melt blown, we cannot use it for coveralls to make it. But SSMMS is better, so we will use it. But for mask manufacturing, you can use both, which will come inside. Since the counterpart is going to discuss about the mask, I'm not going to discuss in detail with this particularly now. So SSMMS is a very soft fabric with the 25 GSM, very suitable. And also in the industry, in the medical textile segment, the use and throw gowns, for example, a surgical gown, and particularly if you take even in the hospitals, in the OT, that is operation theater, doctor will wear the normal dress, then he wears a surgical apron. The surgery apron is normally made of cotton fabric. Mostly people just use it once use, and then it is taken for the laundry. So that when the surgery is, particularly if you take ortho, and also you take urinary infection, when such surgeries are made, lot of blood and liquids would spread down the doctor's body. So in that situation, what the doctor will do, so the apron would not be sufficient because the liquid will penetrate even the apron. So the doctor will prefer another a protective layer of coat, just a disposable like a coat. So that coat is made of the SSMMS material because that will prevent the all spillages to the entering into the body. So this lightweight coat is also, because that is normally called OT apron. Surgeon apron is there, OT apron, operation theater aprons are normally made with the SSMMS fabric. In that case, people use only with 25 GSM. Just a thin layer is sufficient. This is the special application of SSMMS. Next, please. Right. So this is the recent development. Now, the three fabrics, what we discussed earlier, covering completely about the non-woven segment, the Spunbond, SMS, SSMMS. These three are the Spunbond. The SMS and the SSMMS are technically brought under spun melt category, and the Spunbond is only a basic non-woven category. These three are the important fabrics in the non-woven segment. Now we can discuss what are the different fabrics, that is woven fabrics, can be used for the coverall application. This is very important. So from our experience, the industries even are less aware of such fabrics availability and usage, because in woven fabric also we can use it for coverall purpose. And even the principal pointed out this point very nicely, that because the reusability, this is very important aspect. So when it comes to non-woven, it's all single-use product. So the woven fabric, when we start using it, so we will reuse it. So this is the first fabric. I'm giving you the detail, which is a polyester taffeta. Taffeta is basically a continuous filament, a lightweight fabric, a shiny material with a low GSM. This is a taffeta fabric, a plain weave. So the GSM of this fabric would be ranging somewhere from 40 to 100, and in this fabric, the coating is normally done similar to the spun bond. Coated on one side, poly is also coming with the only coated material. Like PA coating, people do that. So during manufacturers, what is infused, or you can say it is a master batch, it is mixed with antimicrobial chemicals. So to climb the polyester taffeta coating, the fabric itself is completely antimicrobial. So that fabric has also not come. So this fabric is light in weight, and this is very stable and very strong. And since it is a woven fabric, it is breathable. So breathability, again, a question mark with the coating. Suppose if you go for a heavy coated polyester taffeta, again breathability will be challenged. We cannot expect the breathability. So, but this garment is again washable and reusable since it is a woven material. But again, the question is about the coating. Since we do a coating, this coverall is not recommended more than 10 washes. Even practically, people recommend it only for 10 washes, because beyond which the coating would slowly erode away and it becomes ordinary taffeta fabric where the filtration will not be there. So that's why it is recommended only for up to 10 washes. But in this also we can go for seam sealing. So since the antimicrobial coating is done on the fabric, on the coating we can do the seam sealing for extra protection. And this type of coveralls are also sold in the market. Only very few manufacturers are doing it, and the price is working out somewhere around 700 to 1,000 rupees. This is the market price. So comparatively, it is expensive. I told you that this SMS and the SSMMS fabrics, when you make a coverall with even seam sealing, it would be somewhere around 400 only. So here the coverall cost would be doubled. The advantage is, of course, it can be antimicrobial and you can use it for 10 times. Now that is the advantage we get with this. The previous one, all are single-use products. Now this is up to 10 washes we can use the polyester material. So even after 10 washes, the polyester will be there. The problem is the coating. The coating will be eroded. So where you get the openness. So the protection will not be there. That's why it is not recommended more than 10 washes. Next, please. Right. This is how the seam is sealed. And you can see there are two pictures on the machine on the right side. So on the seam sealing operation, where the seam portion is, the left is the tape, the blue color tape, which is just applied, and here it is not simple. We use a hot air for the melting of the tape. The tape is gummed on one side, so it is not just a physical fixation. The temperature is somewhere around 325 degree centigrade to melt the blue color tape. Only the hot air is applied where you can see on the pipe. The green color roller is the pressing roller on which you could see the pipe. So that pipe will be applying 325 degree centigrade hot air. So the blue color tape will be melting and immediately that is pressed on the seam where the molten blue color tape is just fixing very firmly on the seam. This is how the seam is sealed. So you cannot peel it off. When you try to peel it off, it damages the ground fabric. This is applied for the basic Spunbond and SMS fabric. So this is how the hot air is applied. Now from our experience, I would like to share the additional information here. The quality depends on the tape quality, because the testing standards, what I'm going to discuss at the end, depends on the quality of the tape what we use here. And many industries, what I have seen across our country, they use this blue color tape produced from different manufacturers. But when they take the coverall for the testing to Citra or any other laboratories, many of them fail in the seam portion only because of the quality of the tape. So if the quality of the tape is taken care, they will get a quality product. So this is to be understood very clearly. So the quality lies on both the fabric and also the quality of seam sealing. So here the temperature is important and the quality of the tape what we use is very important, because at the testing portion it has to bear a lot of pressure. So that quality that tape has to meet. That's our situation now. Next slide. Now coming to the testing part, which is very crucial, because manufacturing of a coverall, I think nowadays many garment industries who are short of orders, who are free with the 20 machines, 50 machines, many people, they just like that purchase the non-woven fabrics from local suppliers, and just like that they started manufacturing the coverall. And when government insisted quality standards, that government has approved now 10 laboratories across the country. So you have to get a certificate or a approval from those labs only. Of course, there are private labs doing the same test, but only the UCC code. That code is given by only those particular labs. So if you want to get that code, you have to submit your sample to that lab for testing. So when it is submitted for testing, majority of the people failed in the seam portion. I've come across a lot of manufacturers, they contacted me why it is failing or not. So we have to understand first of all the testing parameter. So this is very critical in textile industry because we are not totally accustomed to these testing standards on a regular basis. Because of the COVID situation, many manufacturers jumped into the coverall manufacturing. Now government fixes a standard and they are unable to meet it. Because suppose if you take your regular situation like a color fastness or for example shrinkage of the fabric, so we have a solution, we have the reason. But here we suddenly jumped into manufacturing PPE coverall and we are unable to see or look at the quality part of it, where we can get the quality material. So that is the situation now. So to understand the testing of the PPE, we divide into two segments. One is for export of coveralls, another is for the domestic use. Now the PPT before the slide before you is covering about the export requirements. So this is prescribed by the CDC, that is the American standard. So which is AMA PB70. You can browse in the net. There are 4 levels of classification given according to the application, even in medical sector. For example, level 1 is the basic level and level 4 is the highest level. So 2, 3 also there. Now considering broadly, what is the level 1 and level 4? As I told you earlier, suppose you want to supply a coverall for a doctor who will be in the COVID or any other spread diseasing section, then he requires a level 4 coverall. Suppose you somebody a person working in the reception or in the transport side or in the medical side, okay, in the hospital, they are also a medical worker, but they are not like a COVID doctor. So in that situation, we can recommend level 1 category of the coverall. So that's how it is categorized. So in all the categories like level 1, 2, 3, 4, the coverall should fulfill these 4 testing parameters. Only then it is approved or it is considered equivalent to AMI PB70. So the first testing will be impact penetration. That is the strength of the material on impact. The second is the hydrostatic pressure. In hydrostatic pressure, there is of course an instrument is there where the fabric is just kept and then the pressure is applied. So they will notice the 3 droplets. So somewhere when you keep on applying pressure, the water pressure on the fabric on a particular orifice, the fabric would slightly puncture somewhere and the water droplet would come out. So like that, they will identify up to 3 places. If 3 water droplets coming out, then the test is completed. At that time, they will see the pressure. That is called the hydrostatic pressure, AATCC 127 measurement. So where the levels, for example, you take level 1, the value of hydrostatic pressure would be comparatively lower, and in the level 4, they will ask for a still higher pressure. That means the fabric has to withstand. So here comes the role of the coating of the fabric and the role of the GSM of the fabric. Now if you compare a 50 GSM and a 90 GSM fabric, obviously this pressure can be managed by only a thick fabric like 90 GSM fabric. So the first 2 are the physical phenomena. The third is also physical, but that is very, very important testing parameter normally used. Synthetic blood penetration resistance test, ASTM F1670. So my next slide will be exclusively covering the third one because that is the only difference. I tell you now, as I told you, this slide is completely covering all the 4 testing parameters for export of material. And I told you for domestic use, the UCC is given by CITRO and other testing bodies. They will do testing only on the third one. Only the third one. ASTM F1670, they do the test, but they will do the test on 2 areas of the fabric. That is on the fabric and on the seam portion they will test, and the test report is just binary, pass or fail. That's all. The values are not important. Whether it passes or fails, this is like inspection. So they give only judgment. Whether fabric portion pass, then the seam portion also pass, then your total coverall is passing. Then you get a UCC. Otherwise, UCC is not given. Even if one fails, either fabric fails or the seam fails, the UCC will not be given. The net result will be fail only. So it has to pass both. This is the third one. Then the fourth one is the viral penetration test. How the pathogens are penetrating on the seam. That is also tested under 1670. So these four are the vital testing parameters for export. Okay. Now this is exclusively the synthetic blood penetration test. Now you could see I have shown you a photograph of a clamp and orifice. Inside the white color material is the fabric, and at the top you could see a blue color tube. The blue color tube is the synthetic blood. Now we can ask a question: what is a synthetic blood? We know blood. What is a synthetic blood? Synthetic blood is nothing but a mixture of liquid substances where the surface tension of the liquid is much lower than the water, because the surface tension of the blood is lower. So where the blood surface tension is matched with the liquid surface tension, so they assume it is synthetic blood, because if you take blood, that will clot when it is exposed. Since it is a liquid, the collection of liquid what they use will not clot. So that liquid is pumped through the blue color tube, then the round chamber it enters. Through the glass we could see what happens to the fabric. So in the test there are three types of standards we can follow. The first standard we just discussed, 1670. The second test is ISO 16603. The third test is IS 16546. All the three are possible, but mostly in all the laboratories, the first two are followed. ASTM 1670 and ISO 16603. Many people initially thought that ISO would be comparatively easy to get a pass. But later when I'm going through the complete procedure, people found it little difficult, because in the ASTM, the pressure will be applied suddenly to up to this from 0 to 35 kilopascals, and where the pressure is maintained only for 10-15 minutes. Then the procedure is completed. So until that time, they will just look at this window whether the red color liquid coming out at any point. If the liquid comes at any point in the chamber, that is within the circle, then the test fails. So it has to withstand. But whereas with the ISO 16603, what happens? The pressure is applied gradually in an increased manner. Gradually increasing. First there is without pressure 5 minutes. Then they will increase it to, for example, 3.5 kilopascals, 10 minutes. Then 5 minutes no pressure. Then increase it to 7.5 kilopascals. Gradually they will increase the pressure, and the test procedure would be covering for 45 minutes. On the customer, suppose the customer is asking for the first one, 1670, it is tested. The second ISO 16603, that is also done. So in both the cases you get the same UCA. The important point here is, now you look at the coverall, the test will be conducted at 3 portions on the fabric and 3 portions on the seam. This is very important. Many industries are not aware, because I completely observed 4 or 5 test samples of this sequence in the laboratory, because at that time only even I understood the hot air seam, that is a sealed product, just with 0 pressure I got the total failure. That means once we just kept it and the synthetic blood was opened without pressure, through the seam portion the red color liquid started oozing out without pressure. But it was a hot air seam taped coverall. Very important. That's why I told you the selection of tape quality is very important to get a pass. And in that, they take the specimen at 3 places. That is single joint, they call it. That means maybe in the sleeve portion where you could see the blue color tape, they'll cut 1 sample. Then a double joint, there were 2 tapes crossing. Then at the crotch portion at the bottom, they will take 1 sample. So these 3 portions, and I have seen many samples fail only in the 3rd category, that is in the crotch portion. In crotch portion, you cut the sample and keep it somehow, because the seams are overlapping during the manufacture of the coverall, and the tape is also overlapping. So there are 4 overlapping, that gives minute holes or minute gap through the tape portion and the seam portion, where the liquid with the lower surface tension easily passing through this. So we get a fail. So yeah, better quality of tape and better quality of stitching can only solve this problem, and you get approval. So in fabric, they'll take the it is A portion, like chest portion or the thigh portion, they cut the fabric and test it. So normally 70 GSM and above coated fabrics pass in the fabric stage. That you can keep it in mind if there are any manufacturers in the group who are just watching it. So anything above 70 GSM is preferable with a coating particularly. And this seam seal taping, be careful with the high temperature during the taping. It should not be reduced below 300 degrees centigrade, and ensure a good pressure on the roller where you get a good seam seal, where you get a pass. So government has approved totally 10 laboratories across the country. So 6 ordnance factory units and Citra Coimbatore and DRDO, and then Textile Committee Mumbai, then Nitra Ghaziabad. So these 10 laboratories are really, they are testing and giving the UCC code. So in other private labs, if you want to satisfy yourself, you can conduct the test, but the UCC will not be given. UCC will be given only by the laboratories only. They are authorized to give. This is for the domestic industry. If the UCC is awarded to the manufacturer, that particular person, the company will be listed in their website as a reference for any other buyers. And of course, the buyer has to verify the product before they take the delivery. That is also there in the business. This is for the domestic. Next slide. The woven fabric PPE coveralls. So actually, I belong to Dev Inotech LLP company, where we focus on artificial intelligence, and my company is also giving consultancy to the in the COVID-19 situation. We came across the antiviral possibilities. So we worked for a month's time with this company called Abhinav Fabrics in Karur, Tamil Nadu, and we were successfully manufacturing cotton fabrics with complete antiviral and antibacterial property with the durable water repellent finish also, all together in one fabric of cotton. So that we were able to make it. So with this, the advantages are you can apply this total treatment to 100% cotton or the blended fabric, also cotton, viscose, like that also it's possible, preferably cotton. So the material is treated with antiviral and antibacterial chemical. This difference I will discuss in the next slide. So, and also for water repellency, because if it is hydrophobic in nature, that is an advantage, because all the pathogens like bacteria and virus will live in only the liquid medium. So if it is water repellent, that gives additional advantage of the security. So in this case, seam sealing is not required because the entire material. So all the previous non-woven materials, they do not kill the bacteria or the virus. Well, actually, virus is not killed. Technically, it is only inactivated. For an understanding layman's language only, we use the word kill or destroy. Technically, the virus can only be inactivated. Bacteria, of course, can be killed. We know the difference. Huh? So this is a highly breathable fabric because this is a pure cotton fabric. We produced it with a 40s cotton with a 200 thread count material. The GSM of the fabric was 120, so which was very comfortable, a shirting cloth, you could say. So now this is washable and reusable, and even a surgeon or a doctor who could wear it for one complete shift, he will never feel uncomfortable, because he will feel like as though he is wearing his regular dressing, nothing extra. So that's the biggest advantage, but still the protection is given. Now we'll see in the next slide how the protection is given. This is the mechanism. Actually, this chemical is imported from Haiku, Switzerland. The product is ViroBlock. Now Abhinav Fabrics has got with the trade agreement with Haiku ViroBlock, the official users of the product. So we have been incorporating this finish on all the coveralls, that is medical textile, serge apron, the coveralls, scrub shoots, even they manufacture mask also, of course, all antiviral. Now this picture is showing you the antiviral mechanism to understand. So there are two balls shown there. One is the metal ball, which is we can assume it is a silver ion. We know the property of the silver. Silver ions are capable of destroying bacteria very quickly. But now the question is only with the viral. So viral is very, very smaller in size compared to bacteria. We would say 100 size. So it is very difficult to break because of its surface profile. So now the company has made a compound with the vesicle technology, the silver ion, nano silver, coming with the vesicle technology, which is shown in as a blue ball. So this is the testing against the coronavirus. So the vesicle technology breaks the outer profile, which is a cover profile. Normally, that profile is not broken by the silver ions. That's why silver ions are not highly active against virus, but bacteria it is highly active. So the vesicle technology, this compound, which is a cosmetic grade compound, which will destroy the outer coating, the lipid layer of the virus first. Subsequently, the silver ion will destroy the virus. Of course, there is a video in the YouTube. You could see antiviral block and all. You could see that it's just a 54 seconds video. You can understand it better. So it is a two-phased mechanism. So it is a single compound which breaks the outer surface of the virus, which is the protective layer for the virus. So that is broken by the first vesicle technology, that substance, that compound. Then silver ion breaks the DNA, then the virus becomes inactive. This is how the virus is made inactive. Whereas in case of a virus, in case of a bacterial deposition, vesicle need not be activated. Though the compound is there, silver ion itself can totally destroy the bacteria. So this is the difference between antiviral and antibacterial mechanism. Next slide, please. Yes, the similar thing you could see. So this fabric is completely treated with the substance with a slightly acidical condition. So this is now we normally on the medical grade we apply. So it requires somewhere around 60 to 70 GPL concentration in the stator frame, where the cotton fabric is dipped and then it is dried at a temperature around some 120 degrees centigrade. So now this antiviral finish is totally applied on the fabric, and it is firmly fixing on the cotton material, and this substance is tested against even corona. That is, corona causing virus is SARS-CoV-2, which is a 229E strain. That is a human coronavirus. So the company has tested the substance applied on the fabric, and within 30 minutes 99.9% of the coronavirus is reduced. They have the test certificate also, and subsequently our company, that is Abhinav Fabrics, also applied that chemical. We incorporated on the cotton fabric what we have been using it. So then this fabric also we tested with even MSL Lab UK and also Viru Veritas Delhi for H1N1 virus, and also for this 229E coronavirus, where it is the results are highly encouraging, that within 2 hours of contact time 99.9% virus is reduced. So now we are assured that the fabric is capable of inactivating the virus within 2 hours of contact time. So there is no seam sealing is required. Normally, if you use even a Spunbond or a nano one material, no material is going to destroy the pathogens, bacteria or virus. But now this fabric is very comfortable, breathable, very soft, and regular wearing, but still it is antiviral and antibacterial. So double benefit we get. So for a higher strength only we get the medical grade. So antiviral, it is for 25 washes, and we recommend to further, that is 25 washes. That means the fabric will be antibacterial for up to 50 washes. Next slide, please. So this I already covered. Now I come to only the important point with this, the costing factor, because everybody is now particular about the costing factor. Now I've given in separate color a non-woven coverall. Normally a taped one I take, untaped one you get it for 300, taped one we get it for 400 rupees. So I take only the untaped one, somewhere around 300 rupees, a good quality non-woven coverall. So we use it for only once. 300 rupees you buy it and we are using it, then you are disposing it. So 300 rupees per use. Now the cost is now working out per use. Now if I use this woven coverall, which is finished with the antiviral and antibacterial finish, that is with this IQ material, now the coverall is capable of protecting the person from the virus and bacteria, at least, for example, let us take the 25 washes. Even if the cost is somewhere around 1200 rupees or 1300 rupees, If you divide per day, per use, it is going to be only 50 rupees per use. Now, if you compare the usage cost, it will be much lower, much lesser. I have given the cost only for 25 washes. It is only 50 rupees per use. Suppose if the person uses it for again further 25 washes, that is 50 washes, even more than that, the cost is going to be still much lower. It would work out somewhere around 10 to 20 per usage. So in that way, it is very cheaper. Throwaway price, you get the benefit or the protection from the coronavirus. And again, the another advantage, it's absolutely made of cotton and eco-friendly dyed. So it is absolutely pollution free. So disposal is not an issue, and it is also completely made out of only natural material. So no problem with the pollution and all subsequent issues with that. And now this is in progress. We are trying to integrate these two finishes also in the same material, the durable water repellent and the FR, that is fire retardant. Also, we are integrating for the as a special value added product. We are integrating it to get additional benefit, because the next 4-5 months going to be completely of the rainy season. So this will give another advantage for the wearer. So that's also we are working now. So this is put together, you could see the benefits, like it's a wearable and very comfortable, breathable fabric, just like a regular cotton fabric we use, and completely your body is covered and you are protected with the virus and bacteria fully. These are the total advantages. And besides all, the cost of the usage is much cheaper. That's another advantage. Next slide. Who overall can use this oven coverall? It's limitless. Now we have come across even in the same district, the electricity board, 2-3 engineers got affected. Then immediately what they did, the electricity board came to us and they purchased 50 coveralls supplied to all the linemen and all the workers who move with the society. So we cannot define that. So we can say simply that, and even many people approached us, sir, we want to bring back our son and daughter who are in abroad. They want to travel in the flight. So please provide us some coverall. So they purchased only this coverall and then they sent it by couriers and they used it. So whoever comes in the society, comes into the contact of the public people, market, and all these taxi drivers, shop vendors, sales executive who are exposed to the open society and the mass and all, they can use this. There is no limit for the use. Fine. Coming to the testing part with antiviral, this is important, I will tell you. ISO 18184 is a standard which tells you about the determination of antiviral activity. So for any manufacturer, the product that is sold by the manufacturer should be tested, because many cases what happens, people buy chemicals from some manufacturer. The chemical manufacturer claims their product is 18184 pass, but they incorporate it to their material, and after it is converted into another product, this manufacturer do not want to test it. Okay, because there may be the testing may be, of course it is expensive, I agree, but the product quality depends on the amount of the antiviral finish what we apply. So ensure that the product, the final product is certified 18184, and also you can declare the strain. Even in our case, we tested with H1N1 and with the SARS-CoV-2. So both the cases we tested and we got the pass result. And the third point is very important for any manufacturer. Whenever you buy any product in online, or suppose if any client coming even with the big manufacturers, this is one third point is a hidden criteria. The contact time. For example, if I test if I give a finish to a material and I test it for a 24-hour contact time, what happens? The virus is applied on the fabric, and after 24 hours only, it is again reviewed the colony count. So even if the antibacterial or the antiviral effective is lower, for the prolonged exposure up to 24 hours, majority virus would be inactivated and the bacteria would be destroyed. So I can claim that yes, my material is highly effective, 99.9. But if the same fabric is tested for 2 hours contact time, immediately after 2 hours, if the colony count is done, then it will show its reality. You would find that the antibacterial activity would be only would be less than 3. there is a log FU value would be less than 3. So this also important. So whenever we analyze a report, this is important for a technical person. What is the contact time? You test it for 2 hours or 24 hours. That is important. So with the shortest time, if you are able to achieve higher percentage of virus reduction and log reduction, that is, log reduction should be above 3, then it is a clear antiviral product. The test report should be like that. So in our case, even I could proudly say that we have tested our product for only 2 hours contact time, both H1N1 and SARS-CoV-2, and we got 99.9% virus reduction and log reduction value of 4.71. Next slide, please. Suppose if you want to claim antibacterial alone, then there are 2 standards we can follow. AATCC 100, which is general antimicrobial testing on textiles we can do. Otherwise, the best one is ISO 20743, because this is specific antibacterial activity where we can declare the contact time also 2 to 24 hours you can declare. Normally the 2 strains which are predominantly used in this antibacterial is Staphylococcus aureus and pneumonia. These 2 strains are used. Again, you get antibacterial value and log reduction. The log reduction value is above 3. Yes, it is a highly effective material, or we call it full effect and strong. Next slide. Fine. So with this, I conclude my presentation on the reusable.
Topic is development of anti-pollution face mask, and I'm going to suggest a creative approach that can be done for development of antiviral face mask, and how what is the importance of the chemical coating that can be given to the antiviral face mask for developing antiviral face mask for the fabrics. And so there are some creative approaches which has been discussed with several professors of from the chemistry department, and I have devised a small innovative way to develop this antiviral face mask by using the appropriate chemical coating. So first part of my presentation goes on with the anti-pollution face mask, which I have developed 3 years back along with my set of students in our department. So agenda of my presentation includes introduction and about pollution prevalence and health related disorders, whatever the human being is facing day-to-day life, and necessity of the face mask and the requirements of the face mask, and followed by the research work which has been done in developing the anti-pollution face mask. And final part of my presentation goes on with a novel approach to develop the antiviral face mask and newly devised chemical coating combination, which would be appropriate as per my suggestion for coating on the fabric to inhibit or to prevent the penetration of virus, atmospheric virus inside the fabric layers for developing of antiviral face mask. So, as you all aware, that in recent times India is facing an unprecedented population, especially with respect to this population growth and vehicles, the increased level of transport, the small-scale industries, and so due to this kind of development, it has led to serious ecological imbalance and environmental degradation. So our but we all aim to develop some eco-friendly atmosphere, but the situation is not favoring us because several industries development and the heavy population growth, heavy traffic, and the pollution provided by several vehicles, etc., degrades the environment to a greatest extent. So this rapid population growth, along with urbanization and as well as the industrial development and the increased transport level, has resulted in an increase in level of various pollutants like oxides of sulfur, sulfur dioxide, nitrogen dioxide, suspended particulate matters. This is very, very important. Actually, I will be speaking about suspended particulate matters in forthcoming slides. Suspended particulate matters, then carbon monoxide, lead, ozone, hydrocarbons, etc. So these kind of pollutants, they really pollute the environment, and especially the people who are living in residential areas gets affected, and the industry professionals who are working in various industries directly gets affected, right? So in the entire environment gets degraded. You can see the picture available in this slide. This is the picture which has been taken 4 years back in Delhi, right? And Delhi was ranked as the 41st most polluted cities among the world. right? With annual average level of suspended particulate matter generation, which has been increased to 450 micrograms per meter cube, right? So, which is actually there are for each and every criteria has some particular standard, as everyone knows. The air quality, the ambient air quality, whatever we inhale in day-to-day life, has also some standard, and it should be within the range of 140 micrograms per meter cube for residential areas especially. But the suspended particulate matters which has been generated due to the smokes and fumes produced by these vehicles and other recycling of solvents in industries and other chemicals and various sources of pollutions, which I will be listing in forthcoming slides, nearly provokes the way for increasing the suspended particulate matter level to 450 micrograms per meter cube, which is nearly around 3 times the ambient air quality standard. So as a result of this increase in pollution of suspended particulate matters, these suspended particulate matters, especially they will not be visualized through our naked eye. It will be within the small size of 10 mm or 2.5 mm. It will be within the range of 2.5 mm to 10 mm, which will not be visualized through our naked eye. It can easily escape the fabric layers, whatever we develop. So what it can be N95, it can be any other surgical face mask, etc. These suspended particulate matters will easily escape all the fabric layers, whatever you devise, whether you develop a 2 composite layer or 3 composite layer, doesn't matter. This suspended particulate matters will easily escape the particle and the fabric layers, whatever which is available in your mask, and it will easily enter in your nose, and it will create a serious lung disorders, breathability problems, respiratory problems, etc. So and sometimes the person will be subjected to more fatigue and stress, and it may be fatal also. So considering this serious issue, when you go with the available existing industrial face mask, commercially available face mask, they are capable to protect the people. 2 to 3 years back, there is no awareness regarding mask, right? It is also one of the product that has been manufactured like other products, right? It doesn't uh, create more demand as of now because of the pandemic situation. But the commercially available face masks are able to protect the people against these issues. But still, those masks provide some certain drawbacks and limitations, especially with respect to the filtration efficiency. There is a bacterial filtration efficiency and particulate matters filtration, and price is not affordable by everybody, every individual. The fit and the efficiency in filtration, these are some areas where those industrial masks prevails with certain limitations and drawbacks. So what is this suspended particulate matters? I keep on telling about this suspended particulate matters, right? It should be very clear. So we should everybody knows, it is my duty to illustrate you more about the suspended particulate matters. So they can be categorized into 5 different varieties. One is dust, second one is fumes, third one is mist, fourth one is smoke, and fifth one is the aerosol particles. Dust, it is about 100 microns in diameter. Example, coal, dust, and dust provided from cement, etc. Fumes, they are suspended solids which will be less than 1 micron in particle size, diameter. Zinc or lead oxides will definitely provide fumes. The mist are nothing but the liquid droplets, right, which you can observe in winter season, diameter less than 2 microns. Example, sulfuric acid can also provide mist. Smoke, solid particles of size 0.05 to 1 microns. So, incomplete combustion of fossil fuels is the main source for producing smoke from industries. And aerosol particles, it may be liquid or solid aerosols of less than 1 micron. So, every parameter, if you see, fumes, mist, smoke, aerosol, everything is less than 1 micron in size. So, assume the particle size is very low, very small, which cannot be visualized through our naked eye. And this fabric layers, whatever the industries are developing, right? If they use polypropylene, Spunbond, etc., it may be a good combination. But the fabric which has been devised like lyocell or bamboo, some natural fibers, whatever they utilize for manufacturing masks, they are not in a position to filter this kind of minute particles, and they can easily escape through the mask and attack your lungs. It will enter in your nose, and you will not be able to visualize through naked eye. Such kind of small minute particles are also available in the polluted environment along with the other gases like lead, ozone, other. What then major attack because of this suspended particulate matters is definitely it will create lung disorders, some respiratory problems, breathability problems, etc. So at the pollution prevalence is one of the main source. There I have listed out some 2 or 3 reports or case studies which has been I can tell it as a report from several journals and other academic institutions and industries. So air pollution has remained consistently high and rising. And since air pollution is rising, the suspended particulate matter content also becoming high, and it has led to several health problems. First case study is an epidemiological study published by the CPCB. What is the CPCB? That is Central Pollution Control Board. Found that every third children is suffering with reduced lung function. And second study by Health Effect Institute in Boston estimated at least 3,000 premature deaths are occurring due to air pollution related diseases. We are considering this as a normal issue, but it is a very serious issue. And this World Allergy Organization journal, WAO journal, that also reported high respiratory disorder symptoms. So main problem is with heavy traffic movement, and this W allergy organization also alerts that allergic problems will also get increased as air pollution increases. And most detailed study of beyond all this, detailed study of all pollution resources by IIT report includes wide range of pollution sources, including direct emissions from sources as well as indirect formation of particulates from the gases available in the air. And these are the different sources which pollutes the atmosphere, right? And this is the pie chart represents the different sources which pollutes the atmosphere. So production process contributes around 12%, and domestic sectors contributes around 3%, and fossil fuel extraction and contributes about 19%. Solvent recycling and distribution contributes about 28%. Transport contributes to 24%, and other sectors, other waste contributes to 14%. So each and every, there are, if you count 1, 2, 3, 4, 5, 6 sectors or 7 sectors are available, which pollute the atmosphere to various percentage. First of all, we should be very clear with what are the pollution, what are the different sources of pollution, different types of pollution. So soil pollution, air pollution, vehicle pollution, metallurgical, environmental pollution, domestic and commercial pollution, and industrial pollution. So industrial pollution occupies a major share. Vehicle pollution also occupies a major share. And so, beyond this, in adding further to it, soil, metallurgical, and domestic and other commercial sectors also contributing or polluting the ambient air quality, such that a human cannot live. From now, definitely, if your population is increasing and this urbanization, industrialization is increasing in the sense, I cannot predict this. It will be very tough for us to live. And now itself in Delhi and other countries, polluted metropolitan cities like Calcutta and even Chennai also becoming like that. So people will not be in the condition to inhale the good quality of air, right? And these are the various types of oxides which is available in the atmosphere, especially carbon monoxide, lead, suspended particulate matters, volatile organic compounds, sulfur dioxide, etc. And those parameters which contribute, the percentage has been mentioned in the inside the pie chart, which is contributes several parameters, several sectors which contributes to generation of each and every gases has been mentioned inside the pie chart, which is very clear. So there's no need for me to go in detail with that. So beyond considering all these sources of pollution, mainly we need to concentrate about main polluting sources are the nitrogen dioxide and particulate matters which has been emitted from different sources. Nitrogen dioxide, suspended particulate matter, and carbon monoxide. These three are the major polluting sources. So if you see the annual average values of this nitrogen dioxide observed during last 6 years, right? It is increasing. So it has shown an increase, and the suspended particulate matters generation have increased from 363 to 456 micrograms per meter cube. But I'm not saying the government is not taking initiatives. Government also took, Delhi government, Indian government took good initiatives to reduce the suspended particulate matters generation in the year 2001. But still, after that, follow-up is not there. So since the government has changed, for several governments have been changed. So this again, this SPM level is increased to 19.4% from 11.1%. So this could be due to the meteorological conditions and development of the various industries and other cities. And carbon monoxide, the annual average level of carbon monoxide is around 2000 milligrams per meter cube, which is the danger mark, right? And these are the health impacts. Health impacts in the sense the persons are affected by various types of diseases, which can be categorized into three danger levels. Danger level 1 includes the health effects such as nose and throat irritation, runny nose, and then congestion, sneezing, cough, and other asthma flares, etc. Major sources for this kind of diseases is allergy particulates of danger level category. Level 1 category includes dust and pollutants, molds, fungi, mildews, tobacco smoke, wood smoke, vehicle exhaust, dust, then other insects, etc. Danger level 2 is nothing but infectious agents. The health effects from danger level 2 includes sinusitis, upper respiratory problems, and throat and ear infections, bronchitis, pneumonia, etc. And the danger level 3 includes the toxic compounds. So the infection, the problems which the human beings face from danger level 2 sources is bacterial infections are the major sources. The streptococcus, pneumococcus, then tuberculosis, viral infections, influenza, pneumonia, cold virus, and SARS. SARS is nothing but the COVID-19. And danger level 3 includes the toxic compounds like formaldehyde, carbon monoxide, methylene chloride, nitrogen dioxide, toluene, benzene, tobacco smoke again. And it also creates so many problems for the human beings. So here, the necessity of the anti-pollution face mask is very, very important. And here it can be substantiated based upon the previous problems. The World Health Report, what to say, I'm not able to see the full slide. I'm not able, okay. World Health Report attributes this environmental and urban air pollution, the indoor air pollution, climate change are some of the causes for the various diseases, right? So Delhi government has taken several prolonged efforts in recent years, and the generation of carbon monoxide has declined. But still, there is no specific epidemiological study has been conducted on the impact of air pollution and its effects on human health in Delhi. So some effective solutions are needs to be developed in through advanced research and analysis, and it can be integrated as a government policy. It should be integrated in the government policy in various sectors like transport, health, and it can be suitable for industrial policies also. This has not happened so far. So the research analysis has not been done on the effect of air pollution in a cost-effective manner. So my major objective is to develop an anti-pollution face mask which has both bacterial and particulate matter filtration efficiency. A new attempt has been made by developing a triple layer fabric uh, for efficient filtration purpose. So combination of fabrics that was used by in my research is spunbonded cotton and polypropylene with granular activated carbon filter fabric as a sandwich layer, right? I have used spunbonded cotton fabric as the inner layer and spunbonded polypropylene fabric as the outer layer and activated carbon filter fabric as an intermediate layer, which acts as a filtering membrane as a sandwich layer between these two. So bacterial filtration efficiency of the developed product, whatever I achieved, is acceptable just by the standard norms by 92.8%. I have achieved filtration efficiency, which is in par with the surgical face mask. So in many of the commercially available product does not focus on bacterial filtration efficiency. Hence, that is especially with respect to particulate matters. Hence, this future of filtering the particulate matters and the cost, whatever I impart, the thickness and the subjective trials, whatever I took, added feather to the developed mask, and I'm also I didn't, but at that stage, since there is no demand for mask, I'm not able to commercialize it. But now I am developing side by side other varieties of masks made out of lyocell and bamboo blended fabrics, which I will be commercializing in future. So mask in general, as you all know, it should filter out airborne particles, and it should high quality filter should be there, and it fits proper. It should be having a good fit on our face. So not all the masks are effective against breathing in small pollutant particles. So for masks which should be properly certified, and ratings are also very important. So certification in the sense it should have a proper benchmark standards. It should meet the benchmark standards with respect to quality. So then always we should make sure that mask also fits securely, because every person will be subjected to jogging, walking, he will be doing exercises and day-to-day routine activities. Whatever may be the situation, the mask should be properly fitted on the face, and it should not be there should not be any air leakage, and it should not fall off when you commit with some higher level of activities, right? In different postures, when you climb up or climb down, bending down, picking some objects, it mask should not be in a condition to fall down from your face. That is not a proper fit. So my mask, whatever I have developed, I will be telling at the last back end of my presentation about these results, whatever I obtained with respect to my mask, and fit is also very good when compared to surgical mask. So an analysis before developing my mask, I made a small analysis on the existing products, existing available industrial face masks. Number one is the Vogue mask. It is eco-friendly. I have listed some of the features of available existing masks, and later on I will be discussing about the drawbacks associated with that. So the Vogue mask is eco-friendly. It is a reusable mask. It fits well on the face, prevents breathing free of pollutants. It is comfortable to wear even with helmets. And the second one is Respira. It is soft and easy to adjust and gives a comfortable and close fit, usable for 4 months, and it is ideal for motorists, cyclists, and pedalists. Third one is the Breathe Sportive Mask. It is it has a specialty that filter available in the mask can be replaced in due course of time after rapid usage. Then it is durable, washable, and then easy breathing also, and it doesn't get fogged up. And fourth one is the VCare. As we all know, VCare company, they developed a surgical mask which helps to avoid pollution, comfortable to wear also, and prevents all kinds of infection. And fifth one is the On mask. It has adjustable elastic loops. It gives excellent seal and a proper nose fit. Available in large, medium, and small sizes. Light in weight and comfortable to wear. Washable and reusable. As the principles are pointed out, every product, whatever it developed, should be disposable, and after washable, it should be reusable. Right? So these masks, whatever which I have shown, there are some limitations prevailing in those masks. First one is difficulty in breathing. There is not enough ventilation for as and when we wear the mask, and it is also not smoke resistant. It causes allergy to some people during rapid usage. We cannot wear the mask for hours and hours, because these 5 different types of masks, whatever I have shown, when you wear for any mask cannot be wear for so many prolonged hours, but when you wear this kind of mask, it causes allergy, and it does not fit well, and hence leakages will occur. They do not kill any microbes on. The contaminants also, like the serpentine particulate matters or any kind of oxides from lead and ozone, sits on the top and it will get disposed. So ozone vapors and nitric oxides, these kind of particles are not blocked by those masks, and then those masks are not available in all sizes. These are the major limitations. So whatever I got from various sources about these varieties of masks. So based on this, I have fixed a main requirement for a normal face mask. These are the major requirements which a face mask should definitely possess beyond all other normal expectations. So main requirement of a mask is to protect the wearer from two kind of pollutants. One is respiratory suspended particulate matter with diameter less than 10 micrometer and less than 2.5 micrometer, right? And especially the sulfur dioxide and nitrogen dioxide. Those includes the suspended particulate matters. And it should not cause any allergic reactions to the wearer. Proper fit should be there. It should have a well-enabled ventilation, and it should be comfortable and user-friendly. So based on this, I set my objectives of my research was to develop an anti-pollution face mask. First of all, I need to identify the textile material suitable for development of my mask, and I have to coat the non-own whatever which has been selected with the zinc oxide coating. I have chosen zinc oxide coating, as everybody knows, zinc oxide coating is eco-friendly, and it does not produce any kind of toxic effects, and it is the one and only source to arrest the particular matters at the particular fabric layer, and it won't let the suspended particulate matters to go to the inner layer, right, which is in contact with the skin. So that is a specialty of zinc oxide. And to join and form the tri-layered fabric, to assess the properties of the mask fabric, to assess the main requirements of mother, and I have to see whether the assessed properties meets the expectations of the required mask, and we have to assess the comfortability and fit of the composite fabric. And finally, I have developed the anti-pollution face mask. Outer layer I have chosen is spun-bonded polypropylene fabric, and filtration layer, that is a sandwich layer, is granular activated carbon filter fabric, and the inner layer, which is in contact with the skin, is spun-bonded cotton fabric, which is coated with zinc oxide. The methodology: first, I need to procure the raw material, which is granular activated filter fabric and spun non-woven polypropylene fabric and spun bonded cotton fabric has to be produced. Then zinc oxide coating I have to give on the spun bonded cotton fabric, which is acting as inner layer. Then third part of my methodology includes I have to test for several properties, like especially breathability, on bacterial filtration efficiency, pore size, and I also should subject to field trials, subjective fit analysis, and other comparison within available industrial face masks. Finally, I can develop my product. This is the methodology which I have adapted. So outer layer is not on polypropylene. It has excellent softness, as the previous resource person, Professor Tangavel Saravanan sir pointed out. Polypropylene is highly suitable for any kind of applications, not only mask and another coveralls and other any kind of PPE kits formation, and also for it is the best material which has not been replaced by any material so far with respect to this sanitary napkins, because the top layer saturation is one of the very important challenge which has not been done by any material other than polypropylene now. So now research is going on to replace the polypropylene by using some almond gums and other corn starch, etc., to achieve the top layer saturation in sanitary napkins. But still, successful research has not been done. So sorry for deviating this off my own interest. I told this point is non-woven polypropylene has excellent softness. It is antibacterial, and it has good waterproofing tendency, water repellency, etc. Then other air permeability, which is very important, and it does not cause any allergies to human bodies, and relatively cheap to produce. So main asset of non-woven polypropylene is that it is made of spun bonding technique, which can be recycled. Naturally, this propylene gets decomposed and completely incinerates without any production of poisonous pollutants, which is very important, as pointed out by our principal sir of Osmania University. So anything, whatever we manufacture, it should be disposed without any kind of creating any poisonous effects. Because when you, while speaking this point, one of the major fiber which has been banned 5 to 6 years back is asbestos. So none of the projects you observe using asbestos because it produces some toxic effects during manufacture. So asbestos, it has been banned by the government, if I am not wrong. So in such a case, we should not fiber selection for any product development should be taken with utmost care, such that it should be recycled. It should be in a condition to recycle, and it should get naturally decomposed, and it should not pollute the atmosphere during decomposition. So the polypropylene serves all three purposes, and it does not contain any harmful substances itself, and does not require the use of poisonous gases, wasted oil, or effluents to dispose it. Then it has to go a long way for the environmentally eco-friendly products. So this non-woven fabrics has got environmental benefits over other traditional fabrics and papers with all attributes like softness, air permeability, and dehumidifying capacity, cushioning, that is a resiliency, then lightweight, ability to repel water and evaporate water as and when required, then resistance to mold and insects, etc. So specifications of the polypropylene fabric: thickness I have chosen 0.30 mm, and fabric GSM is around 20, and spun bonding technique is preferred because of its lightweight. And these are the four properties which has been already mentioned in previous slides. Good water repellency, air permeability, provides comfort and dryness, and antifungal resistance. Then intermediate layer, the second layer, because I have chosen 3 composite layer and developed the mask by forming a 3-layer composite. So this intermediate layer after the polypropylene is granular activated carbon filter fabric. It has a greater absorption capability and efficiency. It is a perfect non-woven filter media to arrest particulate matters. So this is also a supporting filter media to arrest particulate matters. And it is the best filter media for removal of acids, bases, gases, and volatile organic compounds, whatever which has been in reaction or which is deposits on the surface. And it is a chemical-free product also. And fabric weight which I have chosen for this granular activated carbon filter fabric is around 120 GSM. greater, it has a greater absorption capability. And as I told, these are the previous points which is available. How this activated carbon works is very important because it works by the principle of adsorption. The process absorption is the process in which by a gas bonds to the surface of a solid. In this case, the solid has activated carbon and which absorbs as much of 60% of its weight in airborne pollutants. So the air passes through the filter, whereas the airborne gases, chemicals, and odors react chemically with the surface of the carbon and gets sticked onto it, and it does not pass the that particular carbon fabric layer, effectively sticking to it. So this clean air then flows through the flows out of the fiber. This activated carbon filters will absorb even a small amount of almost all vapors, and they have a large capacity for removing the organic molecules like solvents also. So they can also simultaneously absorb many different kinds of chemicals, which adds feather to these filters, making more efficient. So it can work in different temperatures, and it is safe for people to handle. So for that reason, I have chosen this carbon filter fabric as the intermediate layer. And inner layer, I have chosen spun bonded cotton fabric, which is a weight 10 GSM, and it is also soft and comfort, non-allergic, breathable, and high rate of absorbency is also there. Zinc oxide coating is a chemical coating, whatever I chosen for development of anti-pollution face mask. It has a great antibacterial resistant and inhibits the mildew growth, and it has a good corrosive inhibiting properties and improves the water resistance, also improve water resistance, improved biocidal and durable properties, and neutralizes the harmful acids. These are the special features of this zinc oxide chemical coating. So I have gone with the testing. So first test, whatever it is, bacterial filtration efficiency as per the standard ASTM F2101. The column size is 5 into 10 power 5 colony forming unit per ml of the bacteria. Bacteria is nothing but Staphylococcus aureus, which I have chosen for my study. And sample size is 10 into 10 centimeter. The media, whatever I have used for carrying out this test is tryptic soy agar, TSA, what we call as TSA. And the technique used is plate count method, and incubation period for testing is 37 degrees Celsius, and the time of treatment is 24 to 48 hours. And these are the test results of bacterial filtration efficiency. Flow rate of aerosol is around 28.3 liters per minute, and the mean particle size of the challenging aerosol is 3.3 micron. Average plate count of positive control is 1740.2. And I have taken 3 trials for positive control. I didn't believe with one. I'm not believing with one such trial. I have taken 3 positive control trials, and come to an average of it has been taken as the final and calculated the bacterial efficiency using C minus T divided by C into 100, where C is the average plate count for test control and T is the average count total for the test sample, right? And so average bacterial filtration efficiency value for my mask arrived at 92.8%. So this is the standard acceptance level for surgical mask is 95%. And comparatively, when for my mask, it has achieved around 92.8, nearly 93%. Hence, I conclude that it is sufficient to filter the airborne particles during peak pollution prevalence according to standard norms. And most of the commercial product fails to filter particulate matters and also fails to kill the microbes. Hence, our developed product gives an edge or adds feather and over other available products comparatively at low cost also. And second test is breathability. That is what we assessed for breathing resistance. At 95 LPM with one layer, I have a breathing resistance value arrived at 19 Pascal per centimeter square. So the differential pressure, the breathing resistance will be assessed using the differential pressure. Differential pressure range as per norms, it should be less than 29 or less than 49. So my mask achieves around 19 Pascal per centimeter squared according to the standard EN 14683. So this differential pressure value for my mask itself is an indicator for good breathability, which is expressed in Pascal per centimeter squared. Then differential pressure of the developed mask is suited according to standard norms and ensures good breathability. The most main drawback is most of the existing commercial products is the breathability. One of the other second main drawback. And our product therefore ensures good breathability. Third test is air permeability as per ASTM D737. I carried out The test pressure which has been imparted in the machine is 125 Pascal, and the test area of the sample is 38 into 38 centimeter. The atmospheric air condition has been maintained. Testing condition has been maintained as 65 plus or minus 2% RH and 21 plus or minus 1 degree Celsius. So my developed mask I received arrived at 117 cubic centimeter per seconds per centimeter square as the air permeability value. So air permeability here decreases generally in with increase in fabric weight. So my resultant developed product weight is less than 200 GSM. Hence, it has a good air permeability. This is because increase in fabric weight will cause the more number of fibers per area and causes the fabric density to increase, which in turn increases the resistance to airflow. And fourth test is this capillary flow porometer is the instrument. I have tested for pore size. Pore size analysis has to be done for any kind of filtering products, especially for masks. And test method, whatever employed is capillary flow porometer, and the type of liquid is Galvic, and type of method employed is wet up and dry up. And pressure flow at smallest pore arrived at 0.547 pounds per square inch, and pressure flow, the largest pore size is 0.028 psi. Bubble point pressure is 0.028 psi. And I have taken 4 trials at 10% cumulative filter flow. It occurs at 163.3964 microns, and 25% arrived at 130, and 75% filter flow arrived at 65 microns, and 90% cumulative filter flow occurs at 40.5. So finally, I calculated the filter flow by using the formula 100 into wet flow divided by dry flow. Average filter flow percentage arrived at 98.07%, which is very, very high. So and this is the graph which intimates the flow rate versus pressure. So when you see from the graph, there are 3 types of same fabric in 3 different conditions I have tested for the flow rate in liters per minute, right? With varying pressure levels. One is the non-oven in wet conditions, the same non-oven dry condition, again the same non-oven semi-dry condition, right? So this red is dry, and blue is the wet condition, and green is the semi-dry condition. As you see from the graphs, as the pressure increases, the flow rate per minute also increases, so the filtration efficiency increases after some times and reaches a steady state as visualized in the graph. The increase of filtration efficiency, uh, what was in the increase of efficiency with time and pressure can be explained that as the particles reach the fabric along with air, so deposition of particle occurs and air alone passes through this and filtration takes place. This collection efficiency for hollow filter fabric attains maximum percentage at short interval of time. So product density is also high, and it offers good resistance to flow of particles and easily separates the dust particles from the air stream. So these features are provided by the granular activated filter fabric, whatever I have employed in the intermediate layer. It has the ability to resist and withstand a particle size up to less than 2.5 microns, and hence filtration efficiency of the product is very, very high. And I carried out a subjective fit analysis, right? Subjective fit analysis with respect to different criteria. So a mask should be tested in these 10 different parameters. Should be fixed for analyzing the performance of the any mask, right? It should be easy to wear, comfort, strap adjustment, proper sealing should be there. Comfort in the sense comfort to breathe, air permeability, everything. Ventilation, and there should be air ventilation, but proper sealing should also be there. There should not be any air gap, because once when you nowadays whatever the mask, whatever you purchase from departmental stores, it is a normal fabric. It may be a cotton fabric. It will not be fitting exactly on your face, and it has several areas for air leakages. In such a case, those leaked areas, easily the airborne particles will get enter and it will attack you. So don't purchase any mask from department stores. Rather than you can purchase surgical face mask alone for protecting yourself. So then ventilation, comfort, and while running you should have a good comfort, and it should be fashionable, and it should be it should have a good filtration efficiency, and it should be cost affordable, and it should have a good performance rating, right? So what happened based on the survey results, I can conclude that overall performance of my developed mask falls under excellent, good, and fair category, and it is acceptable by the customers. The fit of the product seems to be good also according to the survey, and customers prefer it since it is fashionable and also available at reasonable price. And finally, I made any product whatever you develop, you cannot claim that it is better. you have to compare it with available industrial face mask. Only through proper comparison analysis, then based on the results, you can claim that my mask can be somewhat better and it reaches some benchmark standards. It can be marketed. It has ability to get marketed in the society, so that so for that I made a comparison analysis with respect to the fit testing. Fit is very, very important. For garment, we use some different the softwares to create some fit in three-dimensional ways, etc. 3D fit analysis is a very one of the popular area which is having great demand today. There are several machines also which can capture your three-dimensional body postures. So we can move, we can do some exercise. Each and every posture will be captured by the machine, and based on the measurements provided by the machine, we can what to say we can create a patterns, and we can create the patterns, and we can conclude with a suitable pattern, and based on the final concluded pattern we can develop the garment. So this is with respect to the recent apparel size and fit research which has been going on. 2 to 3 years back, a person came to our department and he brought a machine, and he asked all the faculties to stand before the machine. The machine, within a fraction of 3 seconds, it immediately captured the three-dimensional body postures of individual faculty who were standing before the machine. So such kind of advancements has been progressing in day-to-day life, which I don't know everybody knows or not. So fit testing is very, very important. I have done this fit, and fit is also very good for my mask. And this graph illustrates about the particles filtration blocked, and also the fit analysis for when compared with all other varieties of masks. To be while counting, it is around 9 masks available. Vogue mask, then I can breathe mask, respiro mask, Totobogo mask, etc. My developed mask filtration efficiency is, as I pointed out, it comes around 93%, right? And fit is also good. Based upon this comparison analysis, I arrived at good results. So this chart, as I told, explains the commercially available products and the particles blockage and the respective prices in the market. In comparison with this chart, the developed anti-pollution face mask has a good filtration efficiency of 92.8% and nears 95% of filtration efficiency according to the norms, and it equals to the high quality product. In terms of cost of the best product, developed masks are relatively cheaper also and affordable. At the same time, it is proved to be efficient in performance. So I conclude this first part of my presentation in such a way that bacterial filtration efficiency of the developed product is acceptable by the standard norms by 92 point in comparison with the surgical mask. Many of the commercially available face mask does not focus on the bacterial filtration efficiency. Hence, this feature of the product, whatever I have developed, gives that an added advantage and value addition in the market. So cotton is the innermost layer which you have chosen, which is in contact with the skin. Probably there is no allergic reactions or irritation is caused to the wearer. That is one of the important point. And filtration efficiency for the of the granular activated carbon filter fabric is high and has the ability to filter out the particulate matters of less than 2.5 microns, especially the nitrogen dioxide and sulfur dioxide compounds. And the filter flow percentage of tri-layered fabric is around 98.07%. Air permeability is acceptable according to the standard norms and reached 117 cubic centimeter per centimeter square per second. Pressure drop of the fabric is around 20 Pascal, which falls under acceptance level. The price of the product is also reasonable and affordable, and compared to commercially available products, and also gives a high filtration efficiency. Hence, this product, whatever which has developed by our myself and along with my students, is fashionable, reasonable, and affordable with high performance filtration. So this is the developed product. I developed my product in 3 different designs. This is the first product, and this is the second design, and this one is the third. So commercial product, the thickness, if you see, it is will be around 2.17 mm, and product weight will be around 5.2 GSM. My developed product thickness, it is around 1.7. Thickness is also less, and product GSM will be still higher when compared to the commercial product. It's around 6.5 GSM, because GSM on the developed product is comparatively high, which will improve the filtration efficiency. So it is not at all a factor. And second part of my presentation I'm not saying the contents whatever I'm going to deliver now for antiviral face mask development. It is a it is a proposal which has been done in consultation with professors of chemistry department in our college and our department faculty members also. So I'm not saying this is the this will be the effective solution, but I am saying the chemical coating, whatever I will be devising in the slides and other the way of synthesis and the antiviral face mask, the characteristics, the material selection, it can be suggested as one of the new novel approach. It can be a novel approach. It can be a root cause. It can be a route for developing antiviral face mask. And I'm very clear with that. I'm not telling that whatever I'm mentioning from now onwards is the real way of developing antiviral face mask, because there are several masks which has been developed recently by IIT and other several institutes across all over India. Right, N95 during its launch, it has a good demand. Now people starts to don't want to buy N95, and it doesn't have any kind of special feature அப்படிங்கிற மாதிரி ஆஹா ஓஹோன்னு சொல்றதுக்கு ஒன்றும் இல்லைங்கிற மாதிரி நிறைய பேசிட்டு இருக்காங்க. சாரி டு tell in Tamil, because people's mindset and the everyday changing environment changes are required, and the different novel approaches are going on developing this antiviral face mask. So N95 is not at all now having greater demand. Okay, I'm not blaming that. I'm not blaming any of the masks, but my suggestion is that we can develop antiviral face mask with in a cost-effective way by selecting SMS combination. Whatever in PSG, our college, PSG College of Technology, we have a Center of Excellence in Industrial Textiles available in Nilambur, right? It is a part of our college. It's a project which has been sanctioned with the Ministry of Textiles, Government of India, from the Office of Textile Commissioner Mumbai for worth rupees 24.5 crores, which everybody knows. So our college has a Center of Excellence among 8 or 9 centers available all over India. So our college Center of Excellence mainly focused towards industrial and home textiles. In that, they have developed a SMS combination, that is spun bonded, then melt blown and spun bonded combination. So the same approach I have also devised in my research. So this I have applied for a proposal to the Tamil Nadu State Council for Science and Technology for development of antiviral face mask. So some ideas I will be sharing based upon this proposal, whatever device now. So this is a suggestion only, right? So main objective is to design and develop an antiviral face mask, and it should be capable of protecting the individual who is wearing the mask against viruses, microorganisms, fungal infections, smokes, fumes, polluted gases, airborne particles, whatever we have discussed in previous slides, via nano hydroxychloroquine bar silver bar zinc oxide composite coated fabrics. I have chosen this combination: nano hydroxychloroquine, then nano silver and nano level zinc oxide composite coated fabrics for formation of my mask. Though this is really necessary to investigate the effect of the reaction of these nano coated chemical particles with the polymeric structure of the fabrics, because the effective interaction of these nano size chemical particles is the in the material side will act as a barrier against the attack of any viruses, especially atmospheric viruses. Since people used to say this virus, SARS or COVID-19, whatever we have, because whole nation is get affected due to lockdown, and there are several quarantines is happening, several containment zones have been created. So people are suffering in day-to-day life. The routine activities gets affected. Every industry, business, everything got affected. The whole nation is subjected to fatal with respect to this kind of situation. So so funding agencies from various sources which has funds, during April, if you will not believe, during March, April, May, several funding agencies they have devised, they call for proposals. I also applied for DST SERB project in April month, and I applied for Tamil Nadu State Council based upon this antiviral face mask, etc. So it is effective interaction will alone the nanosize particles, chemical particles in the pore size of the fabric alone will attack the viruses. This is an area which in which the demand is higher at present. It has a good demand to protect the people against COVID-19. So my major objective is to develop an antiviral face mask which has both bacterial, fungal, and particulate matter filtration efficiency at lower cost. A new attempt has been devised by developing a triple layer fabric for efficient filtration. The fabric combination, whatever I have chosen here, is entirely different when compared with the anti-pollution face mask, which I have told just before. It will be somewhat similar, but it is different. Combination fabrics, whatever we have chosen, is spun-bonded polypropylene with melt-blown polyester fabric. Again, spun-bonded polypropylene fabric. So outer layer is spun-bonded polypropylene, as like previous, and inner layer is melt-blown polypropylene, polyester fabric. Sorry, polyester. And inner layer is again spun-bonded polypropylene fabric. SMS combination. As this will be the better combination, because why I have chosen this is as our textile department madam has developed this SMS combination fabric already, which is nothing a surgical face mask, and she has tested for bacterial filtration efficiency. It has arrived around 98% bacterial filtration efficiency, which is above the norms, beyond expectations of the norms. For surgical face mask, it is around 95. But the developed mask in PSG Tech CEO into Tech office is arrived at around 98% filtration efficiency. So I thought, why can't I select? So I have already developed anti-pollution face mask. The same thing cannot be repeated. There is no use of going with the same kind of combination. Why can't we choose different combination of fabric? So I discussed with Professor Ravichandran of Chemistry Department, and I also discussed with our department faculties and devised this SMS combination. This and the coating, whatever I have chosen for my mask development is chemical coating, is a nano hydroxychloroquine on silver and zinc oxide composite coating. It will be given to the intermediate layer. I have chosen the intermediate layer here, especially melt blown polyester, because melt blown polyester is the only thing, as you all know, melt blown technology, as will be telling overview of melt blown technology and its highlights. It is one of the filtration layer. It is a filtration layer. But it will be in white in color. The fabric, SMS combination fabric, if you visualize the melt blown, it will be very white and soft fabric. That is the filtration layer. It has a good filtration efficiency. So effective protection of people against this viral attacks is expected. And the commercial available product does not focus on bacterial filtration efficiency. Hence, the future of developed face mask will be adding a feather to it. In recent times, as you all know, India is facing unprecedented growth of pollution-related health disorders and damage due to microorganisms, which causes serious ecological imbalance and degrades the environment. And coronavirus is one such situation among the people has created national lockdown, and the whole nation is affected due to the damage created by the coronavirus. So Maharashtra is rank 1. Delhi in terms of pollution ranked 41, and Maharashtra in terms of virus affected pollution was ranked first among the most polluted cities in the world. Among India, right? This nanoparticle coated antiviral face mask is not available at present, up to my knowledge. But now people would have started developing, because in April month itself, several proposals came from DST. Several call for came from DST, and several people, 250 persons, have applied for funded projects based upon this PPE kit development, as well as the mask development, antiviral mask and antiviral protective equipment, coveralls, etc., medical, surgical clothing, whatever, this and that. So procurement, spun-bonded polypropylene fabric and melt-blown polyester fabric, nano silver particles, nano zinc oxide, and hydroxychloroquine. And stage 2, we have to coat the fabric layer. So 3 combinations I have chosen on trial and error basis with various combination. Nano hydroxychloroquine I can take for 10%. 80% I have chosen zinc oxide, the quantity whatever I am going to take for my combination, and 10% of nano silver. So we will keep the keep fixed the ZNO. So ZNO, as it is well known, antifungal, antibacterial, it may be 80%. It can be a fixed parameter, but hydroxychloroquine and other nano silver, because silver cost per gram cost around 500 rupees, right? I cannot afford so much amount of silver, because it has to be reduced in nanoparticle size. Again, hydroxychloroquine is available only in tablet form. It costs around 10,000 to 5,000 to 10,000 depending on the number of tablets. And again, I have to grind the tablets using milling machine and reduce the particle size of the hydroxychloroquine to nanoparticle size, and then only I have to apply as a composite coating on this chemical combination. So stage 3, I have to test for breathability, bacterial filtration efficiency, pore size and field testing. 4, I have to develop the mask. So outer layer is Spunbond polypropylene, filtration layer is melt-blown polyester, which has been coated with this combination. Inner layer is Spunbonded polypropylene. We can also give various add-on treatments to the polypropylene fabrics. Flame retardancy, antibacterial fluorescent treatment, compounded treatments, mildew, lamination treatment, anything can be given. So melt blown technology is well known. It is polymer nozzle subject to the high speed blowing of gas. So some of the commonly used polymers include polypropylene, polyesters, polyamides, and polysterenes, etc. So they are ultra fine in nature, and which is when compared to other fibers. And the filaments obtained by this technique is also size generally of size 2 to 5 microns. Hence, by modification, the size can be reduced to 1 micron also. Due to the fine size of filaments, the nylon fabric obtained is soft and durable. So melt-blown fabrics are known to have high insulating properties and good barrier properties, which makes them useful in variety of applications. What is the role of nanotechnology? Why I have chosen nano size particle? Because in this global impact of the created due to the coronavirus, right? In so healthcare development, the World Health Organization and other Indian Council for Medical Regulation, every organization, they are not still developing the correct vaccine, etc. So the rapid development of novel strategies is therefore required. So interaction of these nanostructures with the microorganism is fast revolutionizing in the biomedical field by offering advantages to in both diagnostic and therapeutic applications. They offer unique physical properties. They have associated benefits for drug delivery also. So these are mainly due to the particle size, right, which affects bioavailability and circulation time. Then large surface areas to volume ratio, then tunable surface charge of the particle with possibility of encapsulation, and large drug payloads that can be accommodated. So recently, a novel coronavirus in worldwide, in particular, making the global impact. What happens is SARS, nothing but COVID-19, emerged from China. China is a responsible place, as everybody knows. So drastic containment measures, despite this, different measures taken by the government, the spread of this virus is ongoing only. So it is an etiological agent of coronavirus disease COVID-19. It is characterized by pulmonary infection in humans. The efforts of international health authorities are focused on rapid diagnosis and isolation of patients, as well as the search for different therapies which are able to encounter the most severe effects of disease. In absence of a known efficient therapy because of the situation of the public health emergency, it made the scientists to investigate the possible effect of chloroquine or hydroxychloroquine against SARS-CoV-2, since this molecule was previously described as a potent inhibitor of most coronavirus. So, preliminary trials of chloroquine repurposing in the treatment of COVID-19 in China has been encouraging, leading to several new trials. Yes, chloroquine is nothing but amine acidotropic form of quine that was synthesized in Germany by Bayer person in 1934, and it emerged approximately 70 years ago, and it is effective substitute for natural quine. Quine is a compound found in the bark of cinchona trees, which is native to Peru. And it's cured many patients. Around 100 infected patients were treated, and they cured when compared with the core. So our novelty approach in this proposal to develop antiviral mask coated with this combination, and hydroxychloroquine will be reduced to size. And this is the procedure since the composite synthesizes. A composite will be taken in a container, water is introduced, and fabric is dipped into the to introduce the nanopowder coating on the mask at 40 to 50 degrees Celsius, and it will bond well with the fabric. Nanopowders were filled in the fiber pores and due to hydroxyl groups present in the fiber. So applications of my product can be because users who are potential users for this antiviral face mask includes healthcare workers, hospital surgeons, general civilians, COVID patients, chemical industry workers, corporation workers, etc. That's it. Thank you for giving me an opportunity.